I have a problem here that will help us to understand this a little deeper. This problem is an exam problem from years gone by. On the back is another exam problem. We're not going to do that today. We're only going to do the side that has this picture that I've shown up there. Parts A and B are just a review of where we've been. And it'll be very, very easy. So quickly do parts A and B. Very quickly do parts A and B. And then, when you start part C, remember to draw the free body diagram of the simplest object first. Okay, so do A and B, and then go to the free body diagrams. Their review. What we're really worried about is later on. Okay, it looks like most of us are done with A. If you haven't clicked yet, get your clicker points. Just click on anything. Let's get it done. Good. The answer is 75 newtons. Okay, let's do that together. If I draw a free body diagram for block A, I have a weight force, earth pulling on A. That's the mass of A times G. The mass of A is 25, and G is 10, so that's 250 newtons. I then ask, are there any magnets? No. What touches A? The rope pulls with a tension force, and the floor pushes with a normal force and a friction force. And this is kinetic friction. I can hear the scraping going on, and that's going to be the floor on A. Now, I know that there's no acceleration in the y direction, so in the y direction my diagram has to screen balance, so this normal force is 250 newtons. This kinetic friction is always given by the formula, and that's going to be equal to 0.3 times 250 newtons, or 75 newtons. Okay, now, tell me what you put for B, the tension of the rope. Can you use Newton's second law is what I'm asking. Okay, get your attendance points. Good, the answer is 125. Now, this diagram has to screen to the right. That means I need more force to the right than to the left. That means that the tension force has to be bigger than 75. How much bigger? How big is the screen? That's given by Newton's second law, F net equals ma. I'm taking 25 kilograms and accelerating it with 2 meters per second to the right. I need a screen of 50 newtons to the right, meaning I need 50 more newtons to the right than I've got to the left, and 125 is 50 bigger than 75. Okay, now we put this smaller block B with 10 kilogram mass on top of A. There's enough friction between the two surfaces that they move together, they don't slip. We pull on the rope so that we have the same acceleration that we had before, namely 2 meters per second. Clearly, I'm going to have to pull on the rope harder than I was in part A and B. It's going to have to be bigger. The tension is going to be bigger than 125 now. I would ask you to draw a free body diagram for block B. For block B. Okay, that should be plenty of time. It's not that complicated. I have a weight force down that's going to be 100 newtons. The only thing touching B is A, and it pushes, Whenever one thing pushes on another, there will always be a normal force. There may also be a friction force. That means I've only got one more force that I can put on this diagram. And that force can only point to the right, to the left, or it can be zero. Those are your choices. And the question is, what do I want my diagram for B to screen? Do I want it to screen to the right, to the left, or balance? Tell your neighbor, which is it? Okay. Folks, it has to point to the right. Now, here's why. When this was an exam question, we had a lot of people who said, there will be no friction force because it's not moving relative to block A. It never moves relative to block A. It has zero acceleration relative to block A. Here's my answer to that. I go out and I spend a huge amount, $250,000, on the most expensive sports car made. I get in that sports car, it has a nice leather seat. I park my butt in that leather seat and I hit the gas. The car goes from 0 to 60 in 2 seconds. Now my butt never leaves the leather seat. My butt has a velocity of 0 always with respect to that leather seat. Did my butt accelerate? Oh yeah, my butt went from 0 to 60 in 2 seconds and it felt great. That's why I paid the money. We do physics relative to the sidewalk, not relative to the fancy leather seat. We have to be in an inertial reference frame. That's what Newton's first law is all about. The reference frame cannot be accelerating. If A is speeding up to the right and B is moving with it, then B has to be speeding up to the right. And that means this diagram has to screen to the right. And that's going to be a static friction by A on B. Now folks, with your clicker, tell me how big that friction force will be. Okay, get your attendance points. Okay, people, if you chose C, if you chose 80 newtons, I will crush you on the next midterm. I will. I won't enjoy it, but I will. Folks, if you got 80, it's because you plugged into this static friction formula. There is no such formula. That formula is for the maximum value of static friction. We're nowhere close to block B sliding off the back of block A. Nowhere close. So in 99% of the cases, we use Newton's second law. This diagram has to screen to the right. How loud should it screen? F net equals ma. 10 kilograms, 2 meters per second squared. It has to screen to the right by 20. This is the screen. The friction force will be 20 newtons. Don't let me trick you like that on the midterm. Have a great weekend.